Solving equations with technology. This means we get to use our calculator for pretty much everything here, and that's good news, right? So what we're going to do is I'm going to do 22D number 1A here for you and show you how you just pop this into your calculator. So we're going to come over here and into my calculator. I'm going to find that one. I have that one already written out. It's x squared minus 4x minus 1. Graph it, and I want you to have a look and see. This is my graph, and I'm zooming in on it. Remember that we were trying to find out what x values are, right? When we're solving for x. So we're going to use our calculator to solve for x by finding, and notice how I'm going to use my intersections button right here. Not that one, that one. My intersections with the x-axis. I'm looking for what are my x values. So my x value here is 4 equals, let's see, it equals 4.23 or 4.24 if I round to 3 significant figures, and here it's negative 0.236 to 3 significant figures. That's it. Those are my two answers. Now, if I put in a equation that actually has a cube on it here, like this one, I have that one here too. I want you to notice something. When it's squared, we have 2 solutions, and when it's cubed, we have 3 solutions. See these 3 solutions? But I want you to notice the notation that the book is using here. Notice how there's a squiggly equal sign for the 2 that are decimals that they've rounded to 3 sig figs, and there's a real equal sign on the 1. Because if you look at this, this is the 1, right? X equals 1 here. X equals approximately 2.41, and x equals approximately negative 0.414. And that's their numbers here. Okay? So that's this first section, very straightforward. Now, in this section, too, what we're going to do is we have 2 options. We can take this equation here, and we can rearrange it. Subtract 2x from both sides, subtract 1 from both sides, and then we get an equation like this, where everything equals 0, and that's good algebra, right? And then we have an equation that's like these, here on the left, that all we have to do is pop in and graph and look for the intersections with the x-axis. So let me show you that, okay? Let's take off these other 2, and let's look at this one. So I get 2 answers. Notice I've got the answer of negative 0.414 and 2.41, okay? Is that the same equation we just did? See, those numbers are actually, are they the same thing? No. So these 2 numbers are our answers, but I'm going to show you another way to solve these. Let's say you're not so happy with this algebra stuff, it's not your strength. Your other option is to take the left side of the equation, this x squared, and put that in. So I'm going to put that in, so y equals, this is my light blue here, y equals x squared, and put that in. And then you can take the right side of the equation and graph y equals 2x plus 1. That's just my pink line here. Okay? And now we're going to see at what point these intersect. So now I'm looking for the intersections of the lines. I took off that other equation that was in the way, the original problem. I'm going to zoom out. Now, I have these 2 equations now. Y equals x squared, the left side of the equation, right? And y equals 2x plus 1, the right side of the equation. And these 2 intersect. I'm changing my button here, right, to the intersection of 2 lines. And they intersect. Look at the x values of this intersection. The x value is 2.41. Sounds familiar, right? That was one of our solutions from doing the algebra and graphing. And my other value is negative 0.414. That's the other solution I had. So the 2 ways you can solve this, you can graph the left side of the equation, the right side of the equation, and then find your intersecting x values. Or, let's go up here, you can do the algebra and graph the whole equation, right, but equal to 0, and you can find, instead of your you're going to look for your intersection with the x-axis, and I get the same 2 values, 2.41 and negative 0.414. Okay? So that is 2 ways to solve number 2, right? The third kind of problem you have is just to solve simultaneously, and that just means put both equations in to your calculator and use this button here, the intersecting button with the lines, kind of like what we just did with these guys. And again, because we're always looking for what x is, you're looking for what our x values are, here and here. Okay? That's it. So if you need to watch this again, slowly going through it, try some problems, check your answers each time, okay? When you come into class, and make sure you're on track. Wait, don't go away. I forgot to show you number 4. Okay, so let me do 4C for you, just because I don't want you to be thrown off. We've done this before. You can graph simultaneous equations. Here they're asking to find not just the x coordinates, but the actual coordinate of the points themselves between two equations. So I've just graphed these two here. All right, the negative x squared plus 4x minus 7, that's this. And notice this is a parabola, and it's a parabola that is pointing downward, not upward. That's the function of having a negative x squared here. Okay, now I've also graphed y equals 5x minus 4. That's my little light green thing here. And I'm looking for the coordinates, the points of the intersection. So I'm going to, over here on my calculator, choose the intersections. Now, there's going to be a second intersection, right? This line is going to continue and cross more than once. So I'm going to zoom out. There it is. Okay. So now that I have the intersections, it's just saying what's the point. So the point is 3.27, comma 12.3, right? And this intersection is negative 8.27, comma negative 45.3. So don't forget, you can zoom in and out to find your values. All right? Now we've covered all the topics. Watch this another time through, okay? Make sure you're ready to do these problems in class. See you soon.